Okay, welcome everyone. Last year I had a little presentation. Yeah, so last year I had a little presentation about the prototype on idea how to support Virtio with Xen using grants, so not compromising the normal Xen security model. And I want to share some updates on the progress of this prototype. And we are sharing this presentation with Oleksandr Tyshchenko from EPAM, who has done some work using the same scheme, building a prototype of his own using a driver domain, but he can tell you more in short time. So I will just report on last year's state, then Oleksandr can take over. And then I will tell you what I have done on the x86 side and the backend side. Okay, so the basic idea is enabling using Virtio inside Xen, but not the dump part, basically, where patches were floating around what is usable already in HVM domains by just using Virtio, using Qemu to map the memory and use it, but to use grants on the guest side to grant the backend access to the arrow pages. Reasoning, of course, is the Xen security idea should be supported. It should be possible to have Virtio backends running in driver domains. And it should be possible to use Virtio even with PV guests without having to add out-of-tree patches to the backend side and in the guests at a heavy scale. It has turned out that it's possible to do all that without having to change the Virtio specification. This is possible by setting a special per device flag, the Virtio as access platform, which enables front end and backend to negotiate that special means of memory accessing should be used. This is mainly used today by 390 PV guests, PV not para-virtualized, but protected virtual machines. And since some time now for AMD SEV guests as well. I've written some guest kernel patches last year, only covering the main architecture, so it wasn't something which already worked out of the box, but was covering basically the parts where we would need to hook into. The idea was to do that at the basic DMA layer, so not having to change each and every front end, Virtio front end for that purpose, but having a central place to do all the changes. And additionally, the idea was to do the same at the backend side. I looked at Qemu and basically identified the places where to do the changes, but I didn't have anything working back then. And now I can just hand over to Oleksandr, who is working at EPAM, based on my work last year, but developing it quite on from that part. Oleksandr, I'm just making you a presenter now. Okay, and I'm selecting your slides.
No, he has to select the slides. He has to select, you're not presenting, you can't choose the slides.
Oh, okay. So
he has to
make presenter. And now, what was it? Shared notes, right?
Plus.
Ah, that one. Right.
Yeah, so it's just right here.
Yeah. Two parties working at the mouse isn't good.
Yeah.
Okay, and then we can make you presenter.
Okay, thank you. How to navigate? Ah, I see.
You can just use the left and right arrows on your keyboard.
Ah, I see. Thank you. So, hello everybody, my name is Oleksandr Tyshchenko. I'm a software developer at EPAM System Ukraine. I'm focused on Xen on RAM. Last time it is mostly Virtio support and everything related to it. Today I'm going to talk about the Virtio support on Xen on RAM. I will briefly describe what is already done and stream it, some kind of weather report. After that, I will talk in detail about the solution based on Xen grand mappings as a safe and secure way for the memory sharing. It is already upstreamed and supported on RAM, so I will describe how it works. I would like to say that Virtio is so important in embedded world as well. For the instance, the Virtio usage is a strict requirement for the automotive domain. There are a few Virtio-related activities I am aware of. Some of them are already described on corresponding Xen wiki page. Some of them are not yet, such as various Linaros and RAM activities targeting Virtio backends. I am going to talk about the Virtio activities in which I am involved in. If you navigate to Xen wiki page, you will see the development approach named Virtio using IREX server and foreign mappings. That development approach is based on Xen's ability to trap and decode guess accesses to memory and forward these accesses to the backend for the future emulation, and the backend's ability to map arbitrary guess pages to access guess data. So with that approach, it is possible to run the guess completely unmodified, but all guess memory is accessible by the backend. Everything needed for that approach to work is already upstreamed. More detail here. IREX server is a key component here. The IREX server and device model were x86 specific features initially, but they were made common and ported on RAM. Guess notification. The device model operation hypercall collection was extended with new ARM-specific hypercall for the backend to be able to notify the frontend using the SPI, shared peripheral interrupt. Memory sharing. Backend uses the functionality for the privileged foreign mappings to be able to access guess memory. The foreign mappings are supported for all domains on RAM as we already implemented the proper reference counting of foreign entries. So it is possible to run the Virtio backends in non-hardware domains as well, but of course, this domain should be trusted. Also, some work to improve and harden grand and foreign mappings in Linux has been already done. I am speaking about new feature on RAM named extended regions. So the idea here is that Xen calculates and reports extended regions to the guest via device tree or ICPI means. The extended region is a region of guest physical address space which is unused and could be safely used to create external mappings. So with that, we don't waste domain RAM pages anymore for creating external mappings when using new Xen. So we don't need to worry about the possibility of exhausting host memory when we need a lot of foreign mappings, as extended regions are big enough. The extended regions are supported for all domains on RAM. Also, the grand table support in Xen itself was improved and hardened. I'm speaking about simplified M2P-like approach for the Xen heap pages mapped as RAM. The last bit is the proper configuration support. ToolStack needs to know how to deal with such Virtio backends that only rely on the Xen stored data. Also, we need to allocate Virtio MMI parameters, interrupt and memory range for every Virtio device and insert the resulting Virtio device node into the generated guest device tree. This is supported as well. Worth to mention that only Virtual block device configuration is supported for now, but support for other configurations, network, etc. can be added using existing example, I hope. Everything would be wonderful if it wasn't a valid concern from security point of view, which was outlined several times from various mainline discussions. The concern is that with foreign mappings, all guest memory is accessible by the backend. So the malicious backend running in non-trusted domain can take advantage of this. The more, without specific XSM policy, The malicious backend could even access hardware's domain memory. This also worries us at EPAM, as we would like to run Virtio backends in non-hardware domains, in driver domains. While investigating how to restrict the Virtio backend, I considered a few possible approaches. Some of those approaches I analyzed in detail in prototypes. The possible approaches how to restrict the Virtio backend are summarized on the slide. I just would like to say that Qemu community is not the single hypervisor community which is interested in creating less privileged backend. This is also an area of interest for the Linaro project Stratus. Before focusing on using grants for Virtio, which became a final choice, I did investigations of Virtio IMMU. I even created a POC. I haven't made it public. I discussed it with Qemu ARM maintainers internally. After the long discussion and realizing what the proper solution would really take, it was decided not to stick to that approach, but look at using grants for Virtio. The grant-based approach wouldn't require any modification to the Xen himself and would likely be welcomed by the Xen community. If you navigate to Xen Wiki page again, you will see the development approach named Virtio using Xen grants. Jürgen Gross, the author of that approach, shared his Linux patches and provided the support. I was wrong when initially thought that Jürgen's solution would require modification to the Virtio infrastructure specification. As it turned out, no modifications were needed. In general, any existing frontend should work with grant reference if DMA API are used for the operation with virtues and DMA addresses are 64-bit addresses. Also, for this to work, we need the ability to allocate consecutive grants for multi-page allocations. After playing with patch series and making sure that it would work nicely, I extended it, added mission functionality, made it functional on RM with device 3. This is already upstreamed to Linux. Jürgen has made the restricted memory access under Xen more flexible. Initially, the restricted memory access was global, but now it is per device. Jürgen has already upstreamed that. As I already mentioned, the grant-based approach requires zero changes to the Xen itself. However, some work should be done by the tool stack. I'm speaking about some additional information to be passed to the guest. Tool stack ARM side is already upstreamed, but of course, there is some work to do on x86. So how does it work on RM? For the HVM guest with restricted memory access enabled and without forcing grant usage, only Xen Grant DMA devices are required to use grants. In a nutshell, Xen Grant DMA device is a device which is marked by the tool stack as one that is required to use grants for the Virtio. But in general case, it could be non-Virtio device, as there is nothing Virtio specific here. On RM, we reused generic IMMU device 3 binding to communicate Xen-specific information for the devices for which the restricted memory access needs to be enabled. In order to reuse IMMU binding, we introduce new Xen Grant DMA binding and stop IMMU driver. We use endpoint ID to pass the backend's domain ID to the guest. The backend's domain ID is needed for the grant mapping API. The tool stack just needs to create specific IMMU node and insert IMMU's property pointed to that node into all virtual device nodes. Those backends are going to run in non-hardware domains which are not trusted by default. The guest then will use that information as an indicator to enable grants for these devices by assigning Xen grant DMA operations. This feature works out of the box on RM. No extra patches are needed. All we need to do is just use upstream Linux and Xen versions and build Linux with corresponding configs enabled. But of course, there is some work to do on x86, at least to find a way how to pass the backend's domain ID to the guest. Unlikely the device 3 will be used for this purpose. In that picture, you can see two different types of virtual devices running within the same guest, usual and Grand DMA device, thanks to the flexible restricted memory access per device. Device 0 is not required to use grants. This is fine as long as it's backend running in domain 0, hardware domain. But device 1 is required to use grants, so its backend running in domain D must support grants, otherwise the device 1 won't be functional. You can see that generated by the tool stack device 3 snippet, which represents the device 1 with IMMU's property inserted. Stream ID here means the backend's domain ID. Virtio disk is a reference Virtio MMI backend implementation. This is a first fully working prototype for Virtio block device on Xen without compromising Xen security model. In that picture, you can see the backend structure. The Xen-specific components here are colored. The new components here is Xen GNT tab, which is marked with blue color. Next picture demonstrates the interaction between the Virtio backend and the external world. Xen, with its interfaces, connects the backend running in the host with frontend running in the guest. So what is needed to get it up and running on RAM? Mainline Xen should be built with the following options: IRX server and expert. Mainline Linux should be built with the following options: Xen Virtio should be enabled, Xen Virtio force grants should be disabled. The backend itself is located at Xentroops repository. It supports legacy and modern Virtio MMI transports, foreign and grant mappings. There are 3 possible memory mapping modes supported by the backend. If all passed addresses are normal DMA addresses, we can either map and map IO buffers at every request, or pre-map all this memory in advance and just calculate host address at every request based on incoming guest address. The map in advance options is disabled by the default, so if you are interested in such optimization, you should only enable it if you are going to run the backend in the hardware domain. If all passed addresses are grant-based DMA addresses, we can only map and map IO buffers at every request. We cannot pre-map all this memory in advance or cache mappings, because with grant mappings, the backend can only map granted by the front-end pages and nothing else. What is more, the backend shouldn't keep the granted pages mapped more than necessary. Otherwise, when unmapping the page, the frontend will notice that page is still mapped by the backend and will complain and isolate the page. You can see the example of Virtio block device configuration for the guest. Here we reused XenPV block device configuration by introducing new backend type and specification property. Backend retrieves configuration from the Xen store. The static configuration, which might be useful for the DOM zeroless, is not supported yet. The last thing is tuning. If you are going to run the backend in non-hardware domain, you will need to configure XSM Plus policy to allow the backend to issue device model and foreign mapping hypercalls, etc. Also, you might want to increase the maximum number of grant frames the guest is allowed to use. If you are going to run some application test that requires a lot of grants to be allocated at the same time. Probably that's all. Performance testing. Yes, I performed a basic performance testing, and the performance for the block operations when using grant mappings is just slightly less than using foreign mappings. The performance drop is no more than just 3-5%. I think this is a quite good result for gaining a good security model and without changes to the hypervisor itself. That's all. Jürgen?
Okay, thank you.
and the plus.
Yeah, but first I have to take presenter, right?
Okay. Well, you can take presenter from taking the plus thing, but anyway.
Okay.
It's 623.
Yeah.
Let's see what that is.
Okay.
Roger had a question.
Any plans to add support for Virtio PCI question? Okay, I think we can cover the questions in the end after the rest of my presentation. So I did some additional work for the x86 side. Oleksandr was mentioning which is still required. So I was adding 3 additional small kernel patches for the front-end side, enabling to select using grants for Virtio devices, because this is now a per device flag. I need to flag the devices accordingly. And I have up to now no method to specify the backend DOM ID on x86, so I'm defaulting to DOM0 right now. And I can use only the grant-based team AOPS if I set the config option config send Virtio force grant. So all Virtio devices need to use grants this way. But of course, there are plans to change that. So I scheduled a design session for discussing how to specify backend DOM IDs and stuff like that generally on x86. Okay, on the Qemu side, I've developed my patches from last year a little bit, so this is the reason why I'm still using Qemu based on 6.0, but those should be fairly easy to be forward ported to upstream. I've in total 7 patches. I'm not sure, maybe 2 of those can be dropped, but I just wanted to have the prototype ready for this presentation, so I didn't bother with keeping those patches. And they're not really large patches. You can see it's just 9 files changed in Qemu and quite a decent modification rate. So I had 2 small restructuring patches needed. One might be unnecessary. I've added 1 patch to avoid the automatic unplug of all PCI devices when the PV devices are coming up of a guest. So this is basically just a nice to have because unplugging the Virtio PCI devices, of course, is needed, but you could avoid it by setting a specific guest boot parameter, but this would then mean that the, for example, boot disk or boot network will still be run emulated afterwards. 3 of the patches are adding the grant usage with Virtio. That was the main part, obviously. And the last patch was advertising the specific flag, and Oleksandr pointed out that it would be possible via a Qemu star parameter to avoid that, but that was the easy way to do it. And with that, I have the current prototype state that I can easily use Virtio disk. I probably could use other Virtio backends which are provided by Qemu as well. I didn't try it yet. Main reason you're seeing down here is that the required Qemu parameters are quite extensive. Yeah. Another thing is that using MSI interrupts for Virtio devices isn't working. I think this is related to problem injecting MSI-X interrupt from Qemu into HVM guests. this needs to be sorted out, but it can be circumvented by using the PCI equal no MSI boot parameter for the guest. This is currently only working for HVM guests. PV guests, in theory, could be made working, but on the other hand, there will be needed something, for example, the IOREX server for PV guests needs to work, and the interrupt injection and so on. So I'm not sure which parts would work already and which parts don't. I didn't test it. Maybe most of it will work, but I'm not sure. And I needed to add this device model args line into the Excel config file for starting the test. So it's a little bit, quite a lot of parameters, but on the other hand, it was quite easy to do so after some experiments. Of course, in the long run, this should be handled by the Xen tools automatically and not having to flesh out all those parameters which aren't really obvious to set in the beginning. Doing that, I can boot a guest from a normal Xen PV disk and then mount the dev VDA disk without any problem in the guest and use it, and it's just working without any specific change in the Qemu disk backend, just in the generic part of Qemu, the memory mapping part, which is quite fortunate in my opinion. And then, of course, there's a lot of work left, but I think I've proved that it's possible in principle to use Virtio using grants in Xen guests. It would be nice, of course, to have the same support I've started in Qemu in the backend kernel as well for vhost Virtio devices. Vhost user is another part which probably is partially at least covered by Oleksandr's work, at least in theory. So it's a similar approach, but a specific backend. But I think for vhost user, the main part missing is the communication between Qemu and the daemon or whatever is running as vhost user. And the big question is the Xen tool support. So what should be the config syntax? Should we have specific configs for each device types or have a generic way to configure it? On the other hand, seeing this required Qemu argument parameters is crying for some device-specific configuration support in LabXL, but this should be discussed in a design session I scheduled. So again, the support PV for PV and PVH guests needs to be seen what needs to be done. So the Qemu-based PCI memory map needs at least to be covered somehow. So the guest needs to know about the additional PCI devices. We need to specify the backend domain. We probably want to have something like live migration support. What do we need for that? Hot plug of Virtio devices should be covered somehow. So those are really multiple topics which we should cover in the long run. The performance has partly been answered by Oleksandr already. So the protocol by itself seems to be fairly cheap, which I really like a lot. I would have thought that it's at least 10%, but only less than 5% is really, those are very good numbers. So I think that's it. Are there any questions apart from the Virtio PCI. So Oleksandr already answered. This is on my radar. I think this is meant to be an answer to Roger's question. Are there any other questions? Yeah?
So you mentioned vehicles for backends.
Yeah.
Do you envision supporting or migrating existing backends in some ways? Do we need to change them to vehicles? Or is there some kind of bridge between existing SAMPP backend and vehicles possible? And what do you think about driver domains in this new model?
So the basic question was for vhost support, what would be the needed changes, basically. So this is the same as in Qemu. You need to use the new DMA layer for those guys. So you basically you need this Virtio as access platform flag to be honored and confirmed to the guest. So this is only at the central part of the vhost server in the Linux kernel on the backend side, which needs to interpret this flag when running on top of Xen to use this the grant-based DMA layer, which is already being used in Qemu, and there you need an additional Xen-based driver for the backends to be used. But that's all. The device-specific backends shouldn't need to be changed for that.
That's just common vehicles that change, and all the other ones.
Yeah, right. So it's just the central vhost part in the kernel which needs to be changed, and all the backends and the device-specific backends can stay the same.
I still want the device-specific backend in the driver domain.
Yes, yes, yes. That's the idea. That's basically the same what Oleksandr has done on his side in user mode in the DOM-D, how he called it. But if it's in userland on kernel, it's technically no difference for Xen itself. Of course, the implementation is a little bit different. In userland, you're using the Xen libraries to do the Xen mappings, and in the kernel, you will just need the grant table code to use of the grant table driver. But basically, for the hypervisor or the toolstack domain, it's a similar approach.
Does this allow you basically to use any of the, like, most of, or any or most of the Virtio backends?
Right. So all Virtio backends which are supported by the common grant-based access frame, driver would be supported. So being it USB or SCSI or whatever. So as soon as the underlying Virtio transport layer is supporting the Xen grants, the backend can be used for those Virtio devices. And of course, the front end side would need the guest using the front end would need the same layer, so upstream Linux basically. But of course, you could also add this scheme to, let's say, Windows PD drivers for supporting Virtio. Yeah, Marek?
So for driver domain support, basically the missing part is configuring backend domain somehow, right?
Yeah, right. So Marek's question was, what is missing for driver domain support? Yeah, basically it is the backend DOM ID support. Because yeah, right. Because the PCI device, yeah, it's a little bit complicated. You might, depending on your backend solution, you might need a way to configure the Virtio PCI device. So in Oleksandr's case, this was done via the device tree of the guest, and it wasn't a PCI device, but MMIL based Virtio. And for x86, for example, you need some way to configure the I/O rack server, basically using the correct PCI parameters on the front-end side for the guest using Virtio. And of course, linking that to the backend DOM ID, and that can react on requests.
So I think time is up, and I think we want to.
Okay, so design session is already, well, not scheduled, but it's in the list of sessions, and there will be a design session for anyone interested in it.
Great, thank you.